Good morning, good afternoon, good evening, wherever you're joining us from. My name is Jen Guile. I'll be hosting this webinar today. We'll be talking about API gateway use cases for Kubernetes, and joining me are Alan Murphy and Brian Ehlert. Let's start with Alan. Can you give us a quick hello and intro?
Sure can, Jen. Thanks. Good morning, good afternoon, everyone. My name is Alan Murphy. I'm the product manager for Nginx Service Mesh in the microservices team, along with Brian.
And Brian.
All right. Good day, everyone. And my name is Brian Ehlert, and I'm the product manager for Nginx Ingress controller. Also in the microservices team, work closely with Alan and Jen on our.
All right, so a little bit of housekeeping here. We do have the chat open. Feel free to drop us a hi, tell us where you're joining us from. And we have the Q&A. If you have any questions, please put them there. We won't be answering them through the chat. We'll answer questions both throughout the session if it's relevant to what we're talking about, as well as dedicated at the end of the session. And so, we're here to talk about these API gateway use cases, specifically in Kubernetes. That's where Alan, Brian, and I all play. And, we know, especially over the last 4 to 6 months, that this has become a really top of mind topic for many organizations that are looking to move those functionalities into Kubernetes. And what we hear most often from people is, which tools should I use? Which tools can double for each other? Can I use an API gateway instead of an Ingress controller or instead of a service mesh or vice versa? And so we're going to cover all of that today, including a high-level intro into what an API gateway is. We'll talk a little bit about API management, as well as really getting deep into those core use cases for API gateways, both in and outside of Kubernetes. And then we have a demo for you where we'll look at both north-south and east-west traffic inside Kubernetes, and of course the Q&A. And so before we jump in, we'd like to do a poll. I'm going to go ahead and launch it now. So we have 2 questions. We'd love to know where you are with your Kubernetes adoption and who you are. Just peeking in at the chat. I see we've got Connecticut, Michigan. I'm joining from San Francisco today. We've got Alan, Brian up in Washington State. Go ahead, and if you haven't popped into the poll yet, do let us know where you are. Brian and Alan, what are you typically seeing when you're talking with our community in terms of Kubernetes adoption?
I mean, really, there's a range. Don't let me interrupt you too much there, Alan. But we get a range of customers, and I think it depends. It's a little different per product, right? So we get customers that are just starting on their Kubernetes journeys, and we get customers that are way advanced users, quite honestly, that end up teaching us a few things along the way. So I think it just really depends.
Yeah, I will second that and say we can generally bucketize those customers into categories like vertical. So FSI might be a little more Kubernetes leaning than healthcare, for example. That's a very general statement. And then also somewhat regionally. When you look at the West Coast of the US, those companies, especially the Valley, Silicon Valley type customers, tend to be a little, pushing the envelope on Kubernetes. And then we see that in other parts, such as Australia, which is a bit surprising, but those guys down there are doing some heavy Kubernetes lifting. But otherwise, it's pretty across the board. I agree.
Yeah, it's in some verticals you might not have expected. At least I didn't expect when I worked in those verticals in IT. When I was in banking, I never would have expected Kubernetes in the banking world, and yet it's there. So I mean, I think it just kind of speaks to the larger situation of where we all are and where everybody is in the progression.
Yeah, definitely. We're seeing it both geographically and vertically distributed. I'll go ahead and close this first poll and sharing the results here so you can take a look along with us. So we're seeing really a very common distribution when we run these polls, starting with about 15% who aren't using Kubernetes yet, 34% just getting started, 43% using some kind of a hybrid, and then we have a small group that are microservices first. And yeah, this is definitely very typical of what we're seeing from the community. And then in terms of who's joining us today, almost 50% are developers. And then we've got a nice split between admins or operators and people who've shared in the chat what their role is. I saw some solutions architects. Let's see here. Pretty good distribution. And so, Brian, why don't you talk a little bit about why who you are today matters in terms of this API gateway conversation?
Yeah, so as we look at the distribution of roles, it's not unusual for those people farther on the kind of the right hand side of the equation, the developer side of the equation that's pushing this, right? Because you're looking for flexibility, you're looking for the ability to overload the term agile again, but to be really responsive to what you want to do. And you want to be able to architect your applications in a way that makes sense for you as a business. And I think that kind of speaks a lot to the audience. I mean, the operators are here to learn what they can do and support their internal folks, right? Because they get responsive and they end up having to build these things. But when we look at the developer, the architect crowd, they want to build. They want to know what's the latest, greatest. They want to know what's coming. They want to make the better decisions because they're generally looking ahead from an architect perspective and want to make sure that they have it. And from a developer perspective, it's like, what can I do now? What's the flexibility you bring to me today? And how can I get my needs met?
Yeah, and I'm seeing one of the titles popping out here in the chat, platform architect. We're definitely seeing more people who identify as being part of some kind of a team we're calling platform operations or platform ops. So definitely a lot of different interests here. So Brian, I think we're starting with you in terms of, what is an API gateway? How do we define it in Nginx? Because it's not necessarily an industry standard definition.
Well, and that's an interesting point, Jen. So people talk about API gateway and they talk about API gateway a lot of different ways. We think of it as a set of use cases because we don't necessarily opinionate ourselves on where you apply the functionality. But API gateway, when you look at it, when you think about it from an over the wire perspective, it's a set of functionality of use cases that you can implement at various layers within your topology. So, which is why we talk about it as a set of use cases. It in and of itself, it's not a magic box. It's not a particular appliance, but it's the presentation of some type of API or some type of service, right? That presents, calls, responses for clients, but it's an API pattern. So you might be looking at, as we have in the picture here, so you might have your warehouse API, your other, but what you really want to achieve here and what you really want to accomplish is something that's a little closer of, you've got something that you want to present. Yes, there is some traffic splitting that's in here as you go through and do this, and you've got some backend services behind that. So those are traditionally things that we think of as reverse proxy or ADC functionality. But here we're lumping that together. You might want some rate limiting in there. You might want some additional functionality in there, header manipulation, even as complex as body manipulation is something you might want to put in there for some legacy applications. You might have some particular egress traffic that you might want to handle specific to your application. So generally we think of those as, I have an API, I'm presenting it, and as to contrast that with, it's just web services, web backend, which is what we thought of before we started to talk about API gateway use cases. We would think of it all as reverse proxy or ADC functionality. But now a lot of the market's starting to talk about API gateway. And like I say, it's not so much a single magical thing as it's, what are the things that you want to achieve to support your APIs? So for example, as we talk about rate limiting. You want to protect your services that are sitting behind that, but you want to do it at a layer in the system where you don't need to build that protection into code. Authentication. You want to take authentication or authorization decisions. You don't want to implement that in your code. So we think about that as implementing that at this layer where we implement the API gateway functionality.
Oop. Make sure my mouse works here. So now let's kind of dig into some of these API gateway use cases, and let's start generic, not necessarily in Kubernetes. We see them broadly in 3 groups, resilience, traffic management, security. Alan and Brian, what are you seeing the most of? What's in demand right now?
Yeah, I can start with that one, Jen. One thing to call out that we have to deal with, Brian and I deal with on a kind of day-to-day basis when talking about API gateways, is that term API gateway, as Brian just talked about in the last slide, means a lot of different things. And fortunately or unfortunately means different things in different environments. So if you're talking about Kubernetes, as we had a question about already, or you're talking about outside of a cluster or in a colo data center, the term API gateway can be a bit loaded. So we do like to, instead of saying, X product like Nginx Plus is an API gateway, we like to say X product can solve these API gateway use cases like resiliency, traffic management, and security. So I always like to start with that and just set the tone of talking about the use cases versus the product family. And in that scope, I would say in my world, which is admittedly a bit biased towards low-level Kubernetes infrastructure and traffic management within a service mesh environment, so cluster within the cluster and service to service, security is generally the #1 driver. And it's all the security options that Brian just talked through. It's authentication, it's traffic cleansing or sanitization, it's MTLS, so end-to-end encryption for API traffic. But for me in my world, security tends to be the driver. Brian, I don't know if that's the same that you see or if you see something different.
Well, I'm generally sitting at talking about a different tier in the infrastructure. So we'll see everything. I mean, on a day-to-day basis, you look at the resilience use cases, failover, high availability is something that we work with a lot of customers on, how they can design that in. When you talk about AB, Canary, blue, green, we've put those under the resiliency buckets here, but you can also think of those as, operational tasks, deployment tasks. So, Canary, can we give the controls to the hands of the development team through just driving the configuration alone to explore, making small changes? Can we enable the test team to safely test essentially in production, without production data, through Canary, sit some flags on there and whatnot, and siphon just their traffic off to a specific path. So we're using the same infrastructure, but we're testing and evaluating in a different way. Rate limiting is a great one that we generally do at a reverse proxy ADC layer for protection. You've got specific clients that you want to make sure they don't overwhelm your system, or you have a service that you identify and you just want to rate limit it as it is, and make sure you can do that in there. Service discovery is just a different way that we look at. Protocol transformation is an interesting one. We don't see that a lot in the Kubernetes world, but it is something that customers look at from an API gateway perspective when they start to bring legacy applications or legacy services into a modern application world. So as customers start to get into those hybrid situations where they might have multiple services or multiple things in there, that type of thing does come into play for some folks.
I do see there's a question in the chat about who owns the edge LTM or API gateway. We will definitely get to that. Before we do, we'd like to find out a little bit more about where everyone is with their API adoption, whether it's in Kubernetes or not. And so I'm going to launch a second poll here. And in the meanwhile, if you do have any questions, again, please put them in the Q&A. That helps us track them and make sure that we actually answer them. So as we're waiting for answers to come in on this poll, what are you seeing when it comes to number of APIs and what that means for an organization, needing API gateway functionality?
I'll start with that one. Sorry for that delay, Jen. When we talk about API traffic specifically, it's, this sounds like the same answer we've been given to every question. It really does depend, and it can run the gamut from 0, as we have as an option here. Somebody who hasn't fully adopted that type of architecture that requires service to service traffic. Although I will say that 0 number is probably the smaller bucket in the general, all the way up to customers that have tens of thousands or even hundreds of thousands, depending on the maturity of their application. I'll go back to vertical a bit on this one. FSI or banking tends to drive more API adoption. And it does matter geographically as well. We have certain requirements and mandates in other places of the world outside of North America around things like open banking. And open banking is built on an API first structure. So any bank outside of North America that's required to offer open banking by default is going to end up in the category of more than 100. So it really just depends on where you deploy and what type of application and where you are in that maturity.
Yeah, and then why does it matter about internal versus external APIs? What does that tell you?
Yeah, so back to the example of open banking. Open banking is such a good example and representation of this question because the requirements require banks to offer a certain set of APIs publicly, and you can authenticate to them and you can have validation and all that stuff, but they have to be publicly accessible. But that may be only 10 APIs. So it may be things like, / account validation. Does Alan really have an account on this at this bank, for example? But the backend behind that might translate to a 10-fold number of APIs. So one API coming in that says, is Alan a valid customer of this bank, might turn into 10 different APIs that are internal within the system. So for me, this question points back to infrastructure, where you need to deploy API gateways and how you size and scale the infrastructure that's going to run those. Typically depends on whether you're dealing with more internal versus external, how you authenticate for external, all of that decision-making factors into your architecture rollout.
Yeah, and I'm going to go ahead and end the poll and share the results. And so we're seeing a pretty wide distribution in terms of where people are with API adoption. Again, everywhere from none to 100. It looks like the clusters here are about 23% between 1 to 10 APIs, so just getting started. Another 23% are between 11 and 50 APIs. 51 to 100, we're looking at 15%, and then more than 100 is 23%. And then we have a good amount of people who don't know, which is also typical. And then what's, I think, interesting here on the internal versus external, it's a fairly small group of people who are either all internal or all external, and that's 10% for each of those. The big group here is 65% have both external and internal. And so, Alan, is this pretty typical of what you're seeing?
It is. Yeah, I mean, I think it's a pretty accurate spread on what we see within the market. And again, it's such a big category and such a broad group of people we're talking to here today, but also a broad set of use cases that it's just going to depend on who specifically you're talking to. But yeah, this absolutely lines up with what we see on a day-to-day basis.
Nice. All right, let's talk more specifically about Kubernetes. We've grayed out a couple of items here. So which use cases do you feel are most applicable to Kubernetes? And why are some either you don't see at all or you shouldn't see them?
So I think this is a little bit about where we're talking into the topology, which actually kind of links into our next slide there too when we give this a little different. I want to back up though, because we're getting a lot of questions about ADC. Sorry about the acronym lingo, folks. Application Delivery Controller. So generally when we're dealing with clouds today, we talk about load balancers, and a lot of times they're kind of basic. What we think of as layer 4 load balancers is they're just forwarding protocols around, but they're not really performing any transformation or inspection kind of functions. That's when we start to talk about application delivery controllers, is when you're doing kind of some more advanced shaping on that traffic in some way, some way, shape, or form. So just to clarify that, which I think that kind of plays into the couple of cases that we've grayed out a little bit here, as in they're more compute heavy a lot of times, or they're just, or as Alan was saying in a presentation the other day, is you might only do it once. So you don't need to do it constantly on the traffic. So do it in a place like such as outside the cluster, where you only have to do it one time, and then you can make your constant decisions in a place where they make a little bit more sense, which is inside the cluster. And that's when we start to talk about ingress and service mesh and doing those decisions at those layers.
Yeah, and thanks for that setup, Brian. That's a good point about kind of any function, and this is just a general statement, but any function that you feel you only need to perform once, generally it's a good idea to do that further away from the application. Again, use cases vary, right? This is a very general statement, but something like protocol transformation, you don't need to transform from XML to JSON at every hop in your infrastructure. If you have an application that requires JSON, generally all of the microservices, if we're talking Kubernetes, will be JSON dependent. So you only need to transform from XML to JSON once. And then once you're inside the infrastructure, inside the cluster, then everything is JSON, and that's good. That's a really good example of the kind of do once philosophy. If you need to affect the traffic in one time for all of your infrastructure, then do it at the edge, or even further out from the edge, as we'll see in the next diagram. That's the general way I like to think about, should an API gateway be deployed outside of Kubernetes or inside? What's the use case? What's the function? And do I need to do something every time one service needs to make an API call to another service? And I think, Brian, you'll go into a little more of that on the architecture side in the next few slides.
Yeah, I think it's a good time to move from this more conceptual conversation to practically how do we implement this. And so we're seeing three places where API gateway functionality can be implemented. And, Alan and Brian, you've both alluded to kind of the why behind that. So first of all, it can be at the front door. The next can be at the edge of a cluster, and the third can be down at that service to service level. And so let's, before we even talk about tools and what tool to use for each, let's talk about why you would choose each location. And Alan, the one-time use case is a really good example of something that belongs at the front door. But let's also talk about who owns each location. So let's go from outside in. Who's owning those front door API gateway use cases?
So generally, when we're at the front door, the farther left you are here, the more you're talking to, say, a networking team in a lot of organizations. So you end up with certain business functions. Business rules always apply to these things, right? So there's always business drivers for where things end up being applied within your infrastructure as well. But so, number one there, that's going to be your load balancer. That's going to be your application delivery controller. That's going to be, to Ellen's point, more of a general decision point that applies to everybody. So you might have certain things that you want to do at that level of the topology. As we, start to move to the right, we get into the choice of what are the functions you move closer to your application, or you move into the Kubernetes infrastructure itself. Do you have to do API gateway use cases at number one there? No, you don't have to. You might have some functionality that does make a lot of sense there. As you move to two, you start to blur the lines now between operations folks and networking folks. As we start to talk about ingress controllers specifically, there are aspects of the ingress configuration that make sense to be managed by networks teams. So you may need to do, IP requests or something like that, have an IPAM service, however you construct your workflow within your Kubernetes environment, because there's 100 different ways to do 100 different things, right? So we can pull those things in And yet there's the application teams that might also need to affect part of that. So you can put the controls within the hands of the teams that's kind of farther to the right. So they try to shift left. And what we're starting to see other customers do is actually starting to take some of their network functions and shift those to the right. So we end up with this kind of merge in between. And I think this gets into a little bit where Alan and I start to talk about where you do these, where it makes the most sense. You as a business, you might not want to do a lot of decisions at your layer one, but you might want to move those into layer two, which is there at the edge of the cluster itself, or you might want to move those, as Alan will mention, kind of in three, which is more your east-west layer.
Yeah, I'll good opportunity to jump in. Thank you, Brian. Yeah, so I think you summed it up really well, both on the ownership side, but also the use case side of choosing where in this architecture you want to deploy your API gateway. And to go back to that idea of do once, a topic that we're just starting to see come from customers as a real use case is multi-Kubernetes cluster resiliency, meaning that behind that front door load balancer, I might have two clusters. So now when a service within one cluster goes away or an entire cluster goes away, I need to fail over to that other cluster, or I'm doing kind of more traditional active-active between those Kubernetes clusters. And those are the kinds of opportunities where the NetOps person who might be owning that front door can start to work with the DevOps person who owns the API side and say, well, where does it make sense to do these functions? Should I be offloading user authentication at the front door so that each Ingress controller at the edge of each one of those Kubernetes clusters doesn't have to deal with that? Or does it make more sense for the Ingress controller to take ownership of authentication because it's closer to the app? And that's why I love these diagrams and love this conversation, because it allows us to work with customers and ask those questions back, because there is no cookie cutter pattern. It's different for every customer. And then, as Brian said, as we start to shift further inside the cluster, not only do we have different questions to ask, like, would we ever care about user-based authentication when we're dealing with service-to-service traffic? If not, do we care about service identity and using things like JOTs or JSON Web Tokens to do service-level authentication? We get to ask these new questions in a cluster, but we also have new toolkit available to us in things like service meshes that can handle orchestrating the API gateway sidecars or handling MTLS for SSL lifecycle management and service authentication. So we get new tools to talk about the new use cases that might be owned by traditional buyers or new buyers. But I just love that conversation that we can start asking. And then the last thing I'll add is we start to go further right. Now that we're asking those questions, we also have to look a little more closely on Kubernetes as a management plane. And we have to ask, do we need API-M tools, which is something we don't talk about in this context because we're just talking gateways. But we start asking, do we need API-M tools because Kubernetes can handle some of that? Or are we concerned that we're now deploying 100 API gateways into a cluster where resource constraint is more of an issue than it would be in a cloud environment or in a colo? So again, it's just such a great way of looking, a lens at looking at the API gateway problem, to be able to ask customers, how do you want to deal with this? Have you thought about this? Is there a better way to do this at one of these three hops? So I just love this level of engagement that we can have.
Yeah, and we'll talk in just a moment about more of the why behind this. As we've said, you can deploy a variety of proxies in each of these locations, and we are advocating specifically to use an Ingress controller or a service mesh if you're doing these use cases in Kubernetes, not because they're the only choice, but because they are optimized for these Kubernetes use cases and environments, as opposed to a load balancer, for example, that's being used as an API gateway, comes with another set of requirements. And so kind of the easiest way that we can kind of describe how you make this choice of which tool to deploy where is around ease of use for your team. And where we see most Kubernetes teams being most comfortable is using a Kubernetes native tool. And so what does that mean? That's a tool that was built, designed to leverage Kubernetes to be folded in. They're typically YAML based. And so there's a lot of benefits of adopting a YAML-based tool which doesn't necessarily mean all Ingress controllers are service meshes. It needs to be one that's Kubernetes native and designed that way. Brian, maybe you want to talk in a little bit more depth about the value of using something YAML based, and then just in brief, we'll get over to the demo.
Yeah, and I think I'm going to use this in the context of one of the questions that came up. So from YAML, from a specification, right? We're dealing with the Kubernetes API is really what we're doing here, and we're using the Kubernetes API to drive our configurations, and that forms an object structure, right? So we're using the YAML, so it makes for a nice GitOps workflow. So you can store that in your source control. You can move that over. You can move that over to Kubernetes, and have that configuration applied and have that realized relatively quickly. And it's a nice, easy way to describe some of these configurations. So we spend a lot of time abstracting, kind of the nuances of Nginx, to give an example, into a way that we can consume through the Kubernetes API. And as you start to look at different products and different patterns, we introduce things in a different way. So, YAML, it just makes sense because you have this nice static definition. Everybody can see what it is. It's a declarative type of style. So you could just describe what you want, and then it's up to the system to make that so and apply that. And even though we mentioned fewer tools, we all know that in Kubernetes, we can pile in different aspects and different tools to achieve different functions, right? So you can start to look at integration with things. But when we start to talk about YAML in the Kubernetes environment, we start to talk about, playing well with your neighbors. We as tools have to not only know how to interface with Kubernetes, we have to interface and respond back to the Kubernetes API so other tools can respond to us, because that's part of the contract that we're making when we start to move into this Kubernetes world. We have a role that as a product that we're responsible for in a layer, but there's an expectation that all of our customers have on how we play in that environment.
Yeah, and I mean, the number one complaint that we so often hear about Kubernetes is that it's complex. And the benefit of all of what you just talked about is reducing that complexity and not making things more difficult by adding something that's going to require different workflows or different configurations. And so I'm going to go ahead and stop my share. We do have a pre-recorded demo by our peer, Leif, who's a sales engineer out of EMEA. He's going to show how to use Nginx Ingress controller for a API gateway use case where we're looking to prevent, I believe it's put requests for a get.
Method blocking.
Yeah. Method blocking, thank you, my brain is done. And then after that, he's going to show Nginx Service Mesh doing some HTTPS canary deployments. And so with that, we'll go ahead and probably go off video for a few minutes just to make sure the bandwidth is okay. But we're here to answer questions throughout the demo. So Marco, take it away.
That leads us into the demo portion of today, which is perhaps the fun part. So I'm going to swap over to my environment here. So I'm in a Kubernetes node right now. It's Kubernetes node number 1. This particular environment has 3 separate Kubernetes instances or nodes, K8S1, 2, and 3. I'm simply working on this one because 1 is the first number. You could obviously do this from wherever. So what are we going to do here? Well, the environment is already set up for us in the interest of time. So first, let's have a look at what we have in terms of an Ingress controller. So if I run kubectl get pods on the namespace nginx-ingress, I see that I have indeed an Nginx Ingress controller here. I can step into that Ingress controller to see what it actually is. I could, for that matter, execute the command from outside the Ingress controller, but so now I'm inside of my Ingress controller. You see the prompt changed, and we can have a look at okay, so that didn't have like so. So we see that in this Ingress controller is running on Debian 10, and we can have a look at what Nginx version we're running here. And we see that this Ingress controller is based off an image running Nginx Plus. So this is an Nginx Plus based Ingress controller, which is great news for us. Cool. So we have the Ingress controller sitting up and running as is. And I'm gonna just do a couple of things here. 2 seconds. There. If I go back here, so the Ingress controller would be this fella here, right? That's the one we were looking at just now. So what else do we have to play around with? I'm gonna quick look at what we have here. Yeah, so I'm gonna go into the that folder, and we should have some YAML files available to us here. Yeah. So the Ingress controller is set up with this Cafe virtual server YAML. So let's have a look at what that one has in terms of instructions. So we're using a virtual server. Traditionally, Ingress controllers were specified and configured using annotations, and you can still do that by all means. However, it's quite limited because that means you're limited to the features that the Kubernetes project has specified as features of an Ingress controller, meaning that you would leave a lot of features of, for instance, Nginx Plus on the table, and you wouldn't be able to utilize them because the specifications weren't there for them in terms of annotations. So to rectify that situation, the Kubernetes project implemented custom annotations, which allowed us to specify annotations, allowing us to add features from the data plane, from say Nginx Plus, for instance, into our Ingress controller without that being explicitly specified by the Kubernetes project. That's better. However, that was problematic in itself as well, because, well, for a number of reasons. One of them being that the custom annotations were typically specified globally, which meant it was complicated, very, very complicated for complex organizations to get exactly the flow that they wanted in their traffic. The virtual server kind allows for a much, much more flexible approach to specifying and configuring up your Ingress controller. So we're using that by default. Yeah, so all of this is pretty self-explanatory. We're looking for a host name of cafe.example.com. We have some secrets defined, so certificates and keys for TLS. We have some upstream services specified. We're exposing some ports, and then we're setting up some layer 7 routing rules, path matching /coffee here and /t, and what we will do with that. What I want you guys to pay attention to here is that we're doing some request method matching. So what we're doing is, if the request is coming in as post, we are gonna yield a 403 and reject that request. If it's not coming in as post, it will not fit this match, right? So it'll bypass this entire conditional match, and /coffee, if it isn't post, it'll be proxy passed to the coffee deployment. Or service rather in this case. For the T, there's nothing special there. A request comes in for T, it'll be proxy passed to T, simple as. But this indicates the whole element we talked about earlier about method-based matching and routing. So let's go ahead and play around with that. We are, let's see, I'm just going to get the pods here again. So we have 2 pods here. If we look up here, Let me have a quick look at that one. Yeah, there we go. So the cafe.yaml is specifying the deployments on the service, right? So here for the coffee deployment, we see we have 2 replicas. We set up a service for the coffee as well and all of those things. And then we're setting up the deployment for tea with 1 replica and the service for tea as well. So when we're looking at the pods here, you'll note that I do indeed have the 2 expected pods or replicas of the coffee and the 1 of tea. The walkthrough one isn't relevant for this particular lab, so we can disregard that. So let's have a quick look at the Ingress controller again. There. It is indeed running. Everything is fine. So yeah, load balancer type. All of that's good. And let's have a quick look at the hosts file as well to see that I'm actually resolving stuff here. There we go. It was hidden here at the top. So I have a resolution in HCC host for cafe.example.com. Cool. So that means I'm going to use a curl command here. Most of you will know exactly what this is doing, given the number of architects we have on the call and so on. But essentially, I'm running a get command here. It would do get by default, but I put the method in explicitly just so we can see it. I'm also using the insecure flag here. And the reason for that is it's a self-signed certificate for this fella. So curl would just yield errors if I didn't use the insecure bit. So what am I going to request here? Well, I'm going to request cafe.example.com /coffee. So we should expect to see a 200 response on this because it's not post, right? And indeed, that's exactly what we're seeing. HTTP 200, everything's fine on the /coffee URI. But what happens, I wonder, if I run a post with some data? So it's the same requests, but I'm now using the HTTP verb of post, and I'm also including some data, so an upload body. Other than that, it's the same request. So if everything's correct, I now expect to see a 403, I'm sorry, forbidden. And indeed, that's what we see. And the message, you are rejected, as we saw in dash virtual boom. That's this bit at play, right? So the moment we saw a post request, it fits into this conditional matching, and we're yielding an HTTP 403 with a body of you are rejected. So that is this element at play working exactly the way it's supposed to. So this is an illustration of how we can manipulate things at the Kubernetes Ingress controller side of the game. And you can do so much more than this, obviously. You can have policies at play. You can have web application firewalling. You can do rate limiting, connection limiting, all sorts of funky stuff. So again, most of the use cases of an API gateway can be facilitated simply through the Nginx Ingress controller for Kubernetes because of the strength of the virtual server type. But what about a service mesh then? Because hopefully at least some of you are aware that Nginx has positioned themselves in the service mesh side of the game for a while now as well. So what can we do there? Well, we saw earlier, I'm just going to run get the pods again so we can have a look at that. We saw earlier we have these fellas here, and these are just standard pods, nothing special about them. But I have Nginx Service Mesh installed on this system as well. And there's a command for the Nginx Service Mesh similar to kube control that looks like this, nginx-mesh control. And I'm just gonna give it the parameter of config to see how it's currently configured. So I get the configuration for the Nginx service mesh. And what I want to highlight here is this bit here, right? So I have an injection here, and I have disabled namespaces is an empty collection. Enabled namespaces is a collection consisting of a namespace called tcream. What does this mean? Well, it means that the Kubernetes namespace of tcream, any pod that spins up in that namespace will automatically have the Nginx service mesh sidecar proxy injected into it. So we can obviously do the opposite approach. If we wanted to auto-inject in all namespaces except 1 or 2 or 3 or 4, we would leave enable namespaces empty and just add the exceptions in the disabled namespaces as well. This is for auto injection. You can also manually inject sidecars outside of this scope, but I just wanted to illustrate that the tcream namespace will have auto injections of sidecars. So what does that mean then? Let's go and have a look at the pods in that namespace. So I'm gonna get pods, but I'm gonna specify the namespace of tcream. How does that look? Well, I have a few things here. I have T version 1, T version 2. I have the tcream service. I also have an additional pod, which is there for us to be able to do service-to-service communication a little bit easier. I'm going to step into that in a moment. And you see 2 of 2 here. The reason you see 2 of 2 here is because there are, in fact, 2 containers in this pod. It's the service itself and the auto-injected sidecar. So that's why you have the 2 of 2 here. So I'm gonna go ahead and where am I? Okay, yeah. So I'm gonna do there, yeah. And we should have some YAMLs here as well, and we do. Excellent. So the one that we're going to play around with here is the nsm.yaml. So what's in that? It looks like this. Very simple. We're setting up a traffic split YAML file. What does that mean? Well, the traffic split is useful for all sorts of cool things. Mind you, we're now inside of the service mesh, right? So if we pop back over here and have a look, that means we're dealing with these fellas now, right? So the traffic split allows you to do things like blue-green deployments, canary, etc., etc. Because you can specify. So you have your version 1 of the T service here, but you've recently developed version 2, and you're deploying that out. And you can start to either do a canary deployment, which is what we're going to do now, where you start gradually increasing the amount of traffic that you're sending over to the version 2 of the service. The idea here being that you're obviously doing testing of your version 2 of the T service at several tiers before it comes close to the production environment. But once you introduce it into the production environment, it's typically a wise decision to gradually move traffic over to it. To see if that increases the pressure on help desk or whatever happens. You'll obviously, when you're doing this, you'll log the output of the service and so on and so forth to see if there any errors are occurring as this happens. But anyways, so we have these 2 services. We're currently weighting them 50-50 just for just to illustrate that we're distributing traffic on them. But we're only doing that if we have a conditional match here. We want specifically to find a cookie with a key-val pair of version equals beta. If that happens, we're going to do the split. If we don't see this cookie in the request, we're simply going to send route all the traffic to the T version 1 and business as usual. So let's see here. I can't remember if I applied this YAML file before we started this morning. So I'm just going to do it again. It doesn't matter. Yeah, I had. So nothing changed. Everything is exactly as we were expecting it to be. So again, just to remind ourselves, how does our distribution of pods look here? We have the T version 1, T version 2, and the front-end service. Cool. So I'm going to go ahead and step into the sleep container to do a service-to-service communication. So that's this fella here, the top one. Or not container, pod would be the more appropriate naming convention here. I'm simply gonna step into the interactive terminal of that pod in the namespace, and there we go. And you see again that our prompt changed. We're now inside of the pod. First thing I'm gonna do is I'm simply gonna curl the T-cream service directly. So that's the front-end service there. And I do that by just curling HTTP T-cream service on port 80. And we get a response fine. I'm getting that specifically from the T-cream FD7, etc. server. And if I run this request again and again, nothing changes. I'm getting the response from exactly the same server. However, if I, for instance, I'll just copy out this command. If I run this command and I into the curl request, I add a cookie of version equals beta, we should see a different behavior. And indeed we do. Oh, sorry, there we go. I have another command I made this morning before the session that will show this a little easier. So there. So you see, we're now seeing load balancing, if you will, between the two, because we have the 50-50 weighting. Now, I didn't show you that as we were going through the configurations earlier, but the load balancing method that's implemented here is least time. So that means it won't be exactly 50-50 as it would be if we were utilizing round robin, but it will be somewhere in the vicinity of 50-50, assuming that the services are performing in or around the same way.
We do want to be clear that there are definitely times when a non-Kubernetes tool is absolutely appropriate. And in those cases, you'll want to be looking for something that we call Kubernetes friendly, in that it has a small footprint, it's not very complex, it's not going to take up a lot of resources to run within your clusters. And so there are 4 general use cases that we see where this can be very appropriate. We'll start with business requirements. One possibility is the team owning all of this may not be comfortable at all with Kubernetes yet. And so, the addition of a tool, they may not know YAML. And so that could be a barrier to adoption. And so in those cases, it could be appropriate to choose a tool that they're already comfortable with. So for example, if you're using Nginx Plus as an API gateway elsewhere in your environments and you want to implement it in Kubernetes because it's familiar, that's absolutely fine. Another example would be around API migration. Alan or Brian, can you go into a little bit more depth on what that looks like?
So API migration might look a couple different ways, right? It might be versioning that you're doing, where you might be supporting multiple versions at the same time. It might be transformation, which we talked about earlier, which is a heavier weight thing, where you're supporting both a legacy system and migration to an internal system. We have some customers that do things like that, where they're both splitting off their traffic as well as transforming their traffic at the same time. So this is where it might be the heavier level transformation that we might be looking at. We'll do splitting later on to identify the correct routes.
And then, of course, in the event that you may have some SOAP APIs, which are definitely not ideal for Kubernetes, they don't take very good advantage of that architecture. You really want to be using REST. But if you do have SOAP, you can use an API gateway, a load balancer in Kubernetes to do that transformation to REST. And it's not that you can't use an Ingress controller, but it's a very resource intensive process. And so it's better to centralize that on a separate tool so that you're not slowing down other traffic. And then finally, we definitely talk to a lot of people who are looking to do those API management use cases. And so, Alan, I think you probably have a bit more to share on that topic, right?
Yeah, I mean, the challenge with APIM, as we talked about earlier, is that outside of a Kubernetes or microservice environment in general, you typically would want something that owned the development lifecycle of an API. So defining the API, publishing the API, versioning the API, adding security policies. And while you still need that same concept or those same concepts in Kubernetes, we have that extra orchestration layer that Kubernetes provides us in the form of a management plane. And as we saw from the demo and Brian's conversation just prior to the demo, the way that you interact with the data plane in Kubernetes, so the actual API gateways, should be different than using a traditional APIM tool. So it's just a different way to look at it when you start moving API gateway functions into Kubernetes or into any microservice platform like Docker Swarm, as somebody mentioned in our chat. You do have a new way to do things like publish APIs or create security policies or traffic policies. So APIM in Kubernetes just takes on a different meaning, for better or for worse. But to your point, Jen, if you need a traditional dev portal or API lifecycle management tool, it most likely is one that's going to exist outside of Kubernetes.
Yeah, and I think there was a bit of a follow-on question regarding Docker Swarm. Maybe Brian to address maybe more of a statement, trying to use Nginx Plus for ingress and proxy to Docker Swarm services. What does that look like?
It can be used, but it's different. So like I say, in Ingress controller, we build on Kubernetes because we take advantage of the API. Ingress controller watches the API, updates the API. In Docker Swarm, you don't have that. So you can still use Nginx there, but you have to manage it in a more traditional way, like you do if it was a machine or if it was bare metal. We do have customers that do that. We do have customers that do Ingress controller and then actually have Nginx Plus behind that and do other things. Like I say, and the difference is how the configuration is managed. It's because it's software, it's flexible. You can put it at different places and manage it in different ways for different uses. So, like I say, if the whole Kubernetes native is about taking advantage of that API integration.
And as we're waiting for more questions to come in, an area that we're seeing a lot of confusion lately is around the new Kubernetes Gateway API. What that means, how that's changing things. So, Brian, what would you share with people on that?
Well, first I want to mention, so Leaf presented something that's unique to us as an Ingress controller project. And I will first say there's two Ingress controller projects that go by the name of Nginx Ingress controller. One is the one that we sell and maintain, and you can have Nginx Plus under the hood for. The other one is the community project. What Leaf was showing was the project that we maintain and our custom resources. These were built around role delegation within the business. And if you start to examine where the Gateway API is today, a lot of that was to take a lot of what Ingress historically did and built around the Ingress resource and annotations and everybody having bespoke annotations and no standards and whatnot. And it's kind of an evolution past where we are with our custom resources for Ingress, in that it recognizes role responsibilities. It's trying to pull in the more generic behavior of gateways as it comes to the Kubernetes cluster. We're working on our implementation of that, just like many of our competitors are. But that is an evolving standard on where we are going from at the edge of the cluster and in cluster definition of those types of services. So that is where Kubernetes is headed.
All right, we've got about a minute left. If you're interested in learning more about either of these tools, they're both available through nginx.com. Nginx Ingress controller using Plus under the hood is available for a free trial. If you're looking for the open source version, then of course you can get that on your own. And then Nginx Service Mesh is a totally free download. So with that said, thank you everyone for joining us. Alan, Brian, as always, thank you for your time and your expertise, and have a wonderful day.